Hey everybody, this is Larry. This is me going over. Okay, well, maybe it's not ready yet. Maybe this time I'm too early. Okay, yeah, this is June 6th, and there's me going with the 6th day of June's Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So today's problem is the longest consecutive sequence. So given an unsorted array of integers nums, return the length of the longest consecutive element sequence. Okay, you must run an algorithm that runs in linear time, okay. N is 10 to the 5th. The longest consecutive element sequence is 1, 2, 3, 4. Therefore, length is 4, 9. So yeah, I mean, let's see. There are a couple of ways to do it. I'm thinking about which one makes the most sense. And also, I don't know. It's a little bit weird in the spirit of things, but maybe not. You can probably look things up in whatchamacallit. So there are a couple of ways of doing this, which I said a few times. So yeah, so I usually solve these live. If it's a little bit slow, feel free to watch on 2x, fast forward, whatever you need to do. But okay. So the idea that I had is kind of union find, which is maybe not O of n, depending on how you want to find the Ackermann or the inverse Ackermann function and so forth, which some people are very detailed about it. Others are probably okay. And obviously you can't sort. If you could sort, then this is trivial, but it obviously also takes n log n. The other thing that I'm thinking about is just using a hash table. Can you do this in a hash table? Don't know. Don't know if there's any weird way about it. So what is the length of the longest consecutive? I can't imagine there's anything in place with respect to like weird psycho finding algorithm type thing, but yeah, I mean, I guess hash tables and then a couple of passes. I'm maybe I'm definitely overthinking this a little bit. The idea is no, but no, because then you cannot keep on getting the min in an easy way. So maybe that's wrong. This is an interesting problem. It's definitely something that is not my strength in terms of experience, or you're seeing me live as well, because very rarely do you need to solve things, at least in competitive and O of n times. You can usually do things in n log n times. So a lot of competition problem, they would just not ask this, but maybe it can show up in an interview because it just requires some sort of weird insight, which are not something that I'm attuned to per se. So this may be a little bit slow, and it'll be funny because it may actually be a easy problem. It's just that it's just a different tool set and different skill set, right? This one is 9. So how can you figure it out? Because there are some properties to play around with. The idea is, let's say we pre-processed everything already, right? Then can we, because then here at 4, it's still awkward because it knows that 3 exists, but yeah, I mean, one thing to note is that duplicate numbers don't matter, so we can definitely put it in a set or something. And it's a hash set, but it still doesn't answer the question. Okay, 4, right? You can't really afford to look for a lot of numbers, so you can only look for 3 and 5. But what does that tell you, right? That means that 3 exists, 2 exists, 1 exists. Can we do some sort of, I guess you can, I guess that's what I was trying to think about last time. It's some sort of dynamic programming, but that's really awkward. Is that really the intended solution? And what I mean by that is, maybe let's just do it. It's just a couple of passes. I had kind of this idea in my head for a little while, but it's just feels a little bit weird. Maybe not. Maybe I gotta just step it up and do it. But okay, yeah, let's first put everything in a set. So num set maybe. Naming things is also hard. And then now we get for x in nums. What does that mean, right? So now let's just say best. Let's put in a hash table. A best hash table that this gives us best starting from this number down. Oh, maybe up. It doesn't really matter. It's the same because it's symmetric, right? So let's do it that way. So for x in nums, while x is not in best. But now we want to do it recursively because you want to kind of, I mean, you could do it 2 pass or you could do it recursively or by going forwards and backwards. Let's do it recursively, right? And maybe that illustrates the dynamic programming a little bit better. So let's just type go, go is name. Let's just get best is barely better than go, but get longest increasing, starting from x. And for x is num, it's yeah, okay. So then the answer is equal to 0. Answer is equal to max of the current answer or get longest increasing of x. And then at the end we return answer. And this one we do want to cache. So if x is in best, we return best of x. Otherwise we return best of x at the end, but obviously after we do stuff. Which is that, okay, if okay, yeah. Otherwise, so if let's just say answer is equal to 1 for the current number, assuming that's already in set. So if x plus 1 is in s nums, then answer is equal to 1 plus get longest increasing of x plus 1. At the very end, we just do best of x is equal to answer. And then, yeah, I think this should be good. It's just very awkward. Let's put in the other test as well. Now this is linear time, linear space. Am I missing any edge cases? The length could be 0, so let's try 0 because no, it should be okay. But let's try it anyway. And just some random numbers I plugged in though. It's not that random, I guess. It's fine. Let's give it a submit. Yeah, this one's just a little bit awkward in general because you have to process it multiple times. Well, not process it, but yeah, maybe processing, going through different passes number of times, and that makes it a little bit tricky. But the key thing to notice is just that, you know, maybe in a way this is maybe another way of thinking about this problem. I mean, I said dynamic programming, but this is like topological sort. Yeah, I mean, I think so. The way that I did it is fine, and this is linear time, linear space. The reason why this is linear time is that this function will be O of 1 for every number that's in nums. It will be only, this will be true once, and this may or may not be true, but this is all 1 because it just calls back. So this is all 1, and because we only call each number once, it's in here once, it's going to be linear. This is actually linear time. Well, linear time in aggregate, meaning that this is linear time. Sorry, this is constant time, as we point out. In terms of space, we obviously have a set. We also have a best, which is linear for dynamic programming as well. So if you think about dynamic programming, x could go from, well, x is has to be a number in nums, so which is there are n of these, so it's going to be O of n time. And then O of n space, because each one takes O of 1 space. So yeah, but I think another way of thinking about it is just topological sort, which I think it's maybe the cleaner way. Basically, the idea is that, and maybe that's just the not dumb way of doing it. This is maybe a little bit silly or overkill anyway, because then now you go through the yeah, okay. So another way of writing this is actually exactly the same, but maybe something like, okay, now you did this if x plus 1, or if x minus 1 is not in as nums, then you do this thing. Then this is already enough. Even here, you don't even need to cache anymore. You could just do this. And the reason being that this is exactly a topological sort, because now because one question that I had in the beginning was trying to get the mins, but it turns out you don't have to get the mins, you just have to get, for a string of, or consecutive sequences, you just have to get a min-mo number, and the min-mo number by definition doesn't have x minus 1 in the list. So yeah, so okay, so I think this one is way easier, and also if you had implemented this way, this doesn't have to be recursion, so this could be a for loop, and yeah, I think this is probably the way that I would recommend it, even though you saw me do it 2 ways. But as I always say, hustle, work at it. Clearly there are multiple ways of doing this. 2 of them are both correct and have the same complexity, both linear time, linear space, but it uses different muscles. So, like when you go to the gym, you get muscle confusion, right? So I'm just kidding. Muscle confusion is not a thing. Don't leave a comment about that, please. But it is true that when you work out different muscles in the gym, you get to grow bigger as a person instead of just like, use one muscle and, I don't know, become like one of those people with like a giant upper body, but they have chicken legs or something like that. Anyway, this analogy or whatever has gone too far. I hope you enjoyed it. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, and let me know how you did, this previous contest, this problem. Hope y'all have a great week. Let me know what you did. It's summertime. Hope you get vaccinated and all that stuff. But stay good, stay healthy. I'll see y'all later. Bye bye.